EGR 6163, Project Management, Module 4, Lecture 1, Defining the Project. Project managers in charge of a single small project can often plan and schedule the project without much formal planning and information. However, when the project manager must manage a large, complex project, a threshold is quickly reached in which the project manager can no longer cope with the detail without having a plan. This chapter describes a disciplined, structured method for selectively collecting information to use through all phases of the project lifecycle to meet the needs of all stakeholders and to measure performance against the strategic plan of the organization. The main objectives for this lecture are to identify the key elements of a project scope statement and to understand why a complete scope statement is critical to project success, to understand why it's important to establish project priorities in terms of cost, time, and performance, to discuss the importance of a work breakdown structure, organization breakdown structure, and a process breakdown structure, to create responsibility matrices for small projects, to create a communication plan for a project. The reading assignment is Larson, Chapter 4. There are 5 general steps for collecting project information. Step 1 is defining the project scope. Step 2 is to establish project priorities. Step 3 is to create a work breakdown structure. Step 4 is to integrate the work breakdown structure within the organization. And step 5 is to code the work breakdown structure for the information system. Defining the project scope sets the stage for developing a detailed project plan. Project scope is a definition of the end result or the mission of your project. It's a product or service for your customer or client. The primary purpose is to define as clearly as possible the deliverables for the end user and to focus on project plans. The scope should be developed under the direction of the project manager, customer, or other significant stakeholders. The project manager is typically responsible for seeing that there is an agreement with the owners on project objectives, the deliverables at each stage of the project, the technical requirements of the project, and so forth. For example, a deliverable in the early stage might be specifications. For the second stage, 3 prototypes for production. For the third, a sufficient quantity to introduce to market. And finally, market promotion and training. So we talk about project scope. The textbook gives what's known as a project scope checklist. So on that checklist starts with number 1, the project objective. This is the first step of the project scope definition, and it has to define the overall objective to meet your customer's needs. Step 2 is the project scope description. This step is a detailed description of the characteristics of the product, service, or outcome of the project. Description is progressively elaborated throughout the project. The project scope answers the question, what end result is wanted? For example, if the project is a cell phone, its project scope will be the screen size, battery, processor, camera type, memory, and so on. Step 3 is the justification. It is important that a project team members and stakeholders know why management authorized this project. What is the problem or opportunity the project is addressing? This is sometimes referred to as the business case for the project, since it usually includes the cost-benefit analysis and strategic significance. For example, on a new release project, the justification may be a expected return of investment of 30% and an enhanced reputation in the marketplace. Step 4 is the deliverables. This is what you're going to deliver to the customer, the measured outputs over the life of the project. For example, deliverables in the early design phase of a project might be a list of specifications. In the second phase, deliverables might be software coding and a technical manual. The next phase might be the prototype. And the final phase might be the final test and approved software. Note that deliverables and requirements are often used interchangeably. Step 5 is the milestones. A milestone is a significant event in a project that occurs at a particular point in time. The milestone schedule shows only major segments of work. It represents the first rough cut estimates of time, costs, and resources for the project. The milestone project is typically built using the deliverables as a platform to identify major segments of work and the end date. For example, when is the testing going to be complete? Milestones should be natural, important control points in the project, and they should be easily recognizable for all the project participants to recognize. Step 6 is the technical requirements of the project. More frequently than not, a project or service will have technical requirements to ensure proper performance. Technical requirements typically specify the deliverables or define the performance specifications of your product. Step 7 is the limits and exclusions. The limits of this should be defined. Failure to do so can lead to false expectations and to expending resources and time on the wrong problem. For example, you can set examples of work limits. You can say that work on site is allowed only between hours of 8 p.m. and 5 a.m. Our system maintenance and repair will be done only up to 1 month after final inspection. And the client will be billed for any additional training beyond that prescribed in the contract. Exclusions further define the boundary of the project by stating what is not included. Examples include data will be collected by the client, not by the contractor. A house will be built, but no landscaping or security devices will be added. Software will be installed, but no training given. So these limits and exclusions sort of clarify some things that's not part of the project and are excluded from the project. And finally, number 8 is the acceptance criteria. These are a set of conditions that must be met before the deliverables are accepted. For example, all tasks and milestones are complete. New service processes begin within less than 1% of the defect rate. Third-party certification is required. Customer on-site inspection is required. So these are what is acceptable. Project scope and terms and definitions. So scope statements, these are short 1 to 2 page summary of key elements of the scope, followed by extended documentations of each element. These are often referred to as statements of work. You can also have what's known as a project charter. This is a documentation that authorizes the project manager to initiate and lead the project. This is usually set up by the top level management. This often includes a brief scope statement as well as such items as risk limits, business case, spending limits, and even team composition. When you're dividing the scope, you have to be careful also not to let what's called scope creep develop. Scope creep is the tendency of a project to expand over time. This is usually caused by changing the requirements during while the project is underway, changing the specifications or changing the priorities. Not involving customers early enough can also be a problem. Underestimating the project complexity is also a problem. Lack of change control is a problem. Lack of change control, you have to have a very robust change controls needed to ensure that only the appropriate changes occur in the scope of the project. And finally, gold plating. Gold plating refers to adding an extra value to the project that is beyond the scope of the project. This is very common on software projects where developers add features that they think the end user will like, but they're not necessarily needed. So how do you establish the project priorities? Well, you really have 3 competing criteria, trade-offs that the project manager has to manage. These are cost, the budget, time, the schedule, and performance, the scope. And these are in competition with each other. So a project manager can manage these trade-offs by completing a priority matrix for the project and identifying which criterion is constrained, enhanced, or accepted. So each of these terms means something special. Constrained means that the parameter is fixed. The project must meet for example, the project must meet the completion date, specifications and scope of the project or budget. Enhanced means that the criterion should be optimized. So given the scope of the project, which criterion should be optimized? For example, in the case of time and cost, this usually means taking advantage of opportunities to either reduce costs or shorten the schedule. On the other hand, with regard to performance, enhancing performance means adding value to the project. Except when a criterion is tolerable, not to meet the original parameter. So when trade-offs have to be made, it's permissible to allow, for example, the schedule to slip, or to reduce the scope and performance of the project, or not go over budget. That's what the accept means. So this figure shows the project priority matrix for the development of a new wireless router. So here you can see on the horizontal axis you have time, performance, and cost. And on the vertical axis you have constrain, enhance, and accept. So here, you know, the performance is going to be constrained, time is going to be enhanced, and the cost is going to be accept. So what does this mean? What this means in this particular case is it means that the project manager has determined that the time to market is important to sales. So that's going to be enhanced. The project manager here is instructed to take advantage of every opportunity to reduce the completion time. That's what it means by having time in the enhance. In doing so, going over budget is acceptable. That's where the cost here is accept. It's okay to go over budget. It's not desirable, but it's okay. Now, at the same time, the original performance specifications cannot be compromised, so we have to keep that the same as it was. So in summary, these priority performance matrices for a project is a very useful exercise. It provides a way to clearly establish priorities with customers and top management, so everybody's on board with what's expected with the projects, and there's no misunderstandings. Step 3 is actually creating the work breakdown structure. So the work breakdown structure begins with the product as the final deliverable. From the product, you break the product down into smaller pieces called deliverables. Those pieces are broken down into smaller and smaller pieces called sub-deliverables. You can have multiple sub-deliverables, and even they can be broken down into smaller pieces called sub-deliverables. And finally, it gets down to a point where you have what's called work packages, and these work packages typically are for individual people to work on. So these, for example, like design and testing, for example. These groupings within a sub-deliverable are called cost accounts, and this grouping facilitates a system for monitoring project progress by work cost and responsibility. So typically this kind of structure is best suited for design and build projects that have tangible outcomes rather than process-oriented projects. We'll talk later about another method you can use for process-oriented projects. So how does the work breakdown structure help the project manager? Well, it really does several things. One, it assures the project managers that all products and work elements are identified to integrate the project within the current organization and to establish a basis for control. It facilitates the evaluation of cost, time, and technical performance at all levels in the organization over the life of the project. So it really helps the project managers plan, schedule, and budget the project. It also helps in the development of what's known as the organizational breakdown structure, OBS. This provides assigns project responsibilities to organization units and individuals. We'll talk more about this in a couple slides. The work breakdown structure also provides the opportunity to sum, or what's called roll up, the budget and actual cost of the smaller work packages into larger work elements. It also helps to define the communication channels and assist in understanding and coordinating many parts of the project. We'll talk later in the lecture too about setting up the communication channels. So let's take a look at a simplified work breakdown structure to develop a new prototype tablet computer. So at the top of the chart, level 1, you can see the project name. It's eSlim Tablet X13 prototype. That is further broken down into sub-deliverables at levels 2, 3, 4, and 5. So the levels of the structure can also represent, not only does it break down the final project into sub-assemblies, it also can be used to represent information for different levels of management. So for example, level 1 information represents the project objective and is useful to top management. Levels 2, 3, and 4 are useful for middle management, and level 5 is very useful for first line managers. So looking at this work breakdown structure, you can see level 2 indicates there are basically two major deliverables, hardware and CPU, and there's some other ones that are not listed here, but so you actually have 3 here: hardware, CPU, and some other items. At level 3, you can see the CPU is connected to the 3 deliverables: the power supply, the flash ROM, and the input-output controller. At level 4, you can see the power supply is broken up into the battery and the charger, and the input-output controller is broken up into USB slots, internet, and touch screen. Note here that level 2 hardware skips levels 3 and 4 and goes down to level 5. Oftentimes this is the case, because what this suggests is that for the hardware there's little coordination is needed with at that level, so they can jump on down to level 5. So also notice here that level 5 breaks down the frame, the cameras, the speakers, and the antenna into the work packages. So these bottom levels are the actual work packages themselves, individual work packages that individual members can work on. So this is a pretty good example of a work breakdown structure. So the lowest level of the work breakdown structure is called the work packages. Work packages are short duration tasks that have a definite start and stop point, consume resources, and represent cost. Each work package is a control point, and a work package manager is responsible for seeing that the package is completed on time, within budget, and according to technical specification. Practice usually suggests that a work package should not exceed 10 work days or 1 reporting period. It becomes much more efficient that way. Each work package should also be independent of other work packages in the project as much as possible. No work package is described in more than one sub-deliverable of the work breakout structure as well. So each work package in the work breakdown structure defines what work is done. It identifies the time to complete a work package, identifies a time phase budget to complete the package, identifies resources needed to complete the package, identifies a single person responsible for units of work, identifies the monitoring points for measuring progress. How do you measure how it's doing? So the work breakdown structure is used to link the organizational units responsible for performing the work. In practice, the outcome of this process is the organization breakdown structure. The organization breakdown structure depicts how the firm has organized to discharge the work responsibly. The purpose of the organizational breakdown structure, which is abbreviated OBS, is to provide a framework to summarize organizational unit work performance and identify the organizational units responsible for the work packages. It also ties the organization unit to the cost control counts. So as with the work breakdown structure, the organization breakdown structure assigns the lowest organization unit the responsibility for work packages. Herein, lies a major strength of using the work breakdown structure and the organizational breakdown structure together, because they can actually be integrated together, as shown in the following example. The intersection of the work packages and the organization unit creates a project control point that integrates work and responsibility very nicely. So for example, at level 5, if you go to in this example, you go to the touch screens, you can see it has 3 work packages that have been assigned. Here's one, and here's the other one. So the cost control has been assigned to the design, the QC has been assigned a work package, and the production's been assigned a work package. You can also see, for example, the work package numbers assigned at each level. So level 0 is 1.0, and then hardware is 1.1, CPU is 1.2, and then level 3 is given a 1.21, 1.22, etc., all the way down. You can see here the organization, how it's broken up into the teams, and you can see what work packages are assigned to what division in the organization. So following on from the last slide, you can see how this is coded up. The work breakdown structure coding system assigns 1 as the top level, and from there, as I pointed out, you have 1.1, which is the hardware, 1.2, which is the CPU, and then with under each one of those, it's given a further delineation. For example, the hardware, you have 1.1.1 is the cameras, etc. This is the way it's coded up inside a software package. It's also the way work packages are put on the work package, and it also helps to control the budget and cost information associated with each work package. It provides very detailed information.